Purpose of this video is just to quickly go over what it takes to do algebra in one step with just variables. Now, the purpose of algebra is really kind of to help us have some general rules to solve a particular puzzle. If you do it with numbers, like if I said 7 plus x equals 10, the game is essentially, what could I put here instead of this? X, of course, that would calculate to get this to be correct, that this side is the same as this side. In this particular case, of course, you can probably quickly predict that it's 3. But what the rule tells us, if we kind of want to be able to figure it out without just guessing, it's that if I did the same thing to this side as to that side, they would stay equal to one another. So right now, we're saying that both sides are equal to 10. So what I do is I want to get this guy by itself. So I need to do the opposite to this right here. Since it's being added, technically, what I'm going to do is subtract 7 on this side. But if I do it from one side, now it's not equal. So I must do it to the other side. Now I can see that, okay, x is equal to 10 minus 7, which of course tells us 3, which we knew ahead of time. But this gives us kind of some basic rules to solve more complicated problems. What we are going to do is the same thing, except we are going to do it now with variables or letters. So I might see something instead like this. A plus B equals C. And I must be asked to solve for a variable. Now for starters, how do I know a variable is solved for? Well, one, you will never lose any letters. If I start with these 3 letters, they should be somewhere in the problem at the end. And I know that I should probably draw with a darker marker. My apologies. I know that I am done if that variable is by itself on one side of the equal sign. So if this problem right here had said solve for C, I'd already be done because it's already by itself. If instead it said solve for A, this variable here, what I want to do is I want to get this guy by itself on one side of the equal sign. So to do that, I follow the exact same rules as I did before. Just like I noticed that the 7 needed to be subtracted to get the x by itself. In this case, I want to get a by itself. Let me circle that just to make my life a little easier and say, what's keeping it from being by itself? Well, the b. What is the b doing? It's adding. So I'm going to do the opposite. I'm going to subtract b. But I can't subtract b on one side and not on the other. So I have to do that on both sides. The plus b minus b will cancel. Then I just rewrite what this says. If I look at the left side, I don't have this anymore. I just have A equals C minus B. Now that A is by itself, I'm done. This is the answer to the problem. A is solved for. Now eventually we'll add some more steps. We'll put some numbers in here, but for our purposes right now, that's it. Now this is a type of problem where you're dealing with addition algebra. Addition or subtraction. And what we're doing is, again, looking for what's keeping it from being by itself. Let's look at another example real quick. Let's say I said, I don't know, E is equal to F minus G. Okay? And instead of solving for A, let's go ahead and solve for F. Once again, had it said solve for E, I wouldn't do anything at all. But since it says solve for F, I'm trying to get that by itself. So first I identify what's keeping it from not being by itself, the G. And I need to get rid of the G. So I'm going to do the opposite of whatever it's doing. Since it's subtracting, I add. Since I've added it to one side, I add it to both sides. Minus G plus G will cancel. And now I rewrite. This says E plus G equals F. I don't mind, by the way, if the variable by itself over here is on the right. If it bugs you, you can flip sides. It's not really that big of a deal. Also, in this particular case, if you'd written in a different order, if this had said G plus E, also not that big of a deal, would still be the correct answer. But that's addition algebra. Let's say I have something else. Let's say I have W equals X times Y. Now, since we are dealing with letters here, you'll notice that the multiplication is not going to be necessarily across anymore, maybe like you're used to from other classes, you're either going to see a dot, or actually the most common thing is to not see anything at all, just to see them right next to each other. If they're right next to each other, we know they're multiplying. In this case, let's go ahead and solve for x. So I want to get x by itself. It's keeping x from being by itself, the y. Unlike last time, y is not being added or subtracted. It's being, as we said, multiplied. So what we need to do, multiplication algebra here, okay, is the opposite. The opposite of multiply is to divide. And once again, to make both sides equal, we need to do that on both sides. This side, since we have 1 on top and bottom, will cancel because y divided by y is 1, leaving us with just x. Now I rewrite. This just has x equals w divided by y. That's it. The last piece of this puzzle is a little bit complicated. Let's talk about division algebra. Now, it's not going to come straight out and tell you that there's actually division going on. What it'll more than likely look like is this. It'll say something like k is equal to, coming up with random letters off the top of my head, q over n. Okay? As always, if it had said solve for k, don't do anything, because it's already by itself. But let's say in this case, we're trying to solve for, let's go q. Okay? What we're going to do in this case is first need to identify that we're dealing with division. We know we're dealing with division because we see a fraction. And a fraction is another way of saying divided. Q divided by n can also be written as, like you see here, q divided by n. So you see a fraction, you know it's division. What we will do in this class is if you see a fraction, we're going to make both sides a fraction. K is not yet a fraction, but we always know that any number is kind of invisibly being divided by 1. Now that we have two fractions, what we're going to do is we're going to cross multiply. In other words, literally what it says, just multiply, multiply what's across. So what's on top, what's on bottom? What's on top and bottom would be k and n, so I multiply what's across. K either times n, or again, you don't have to write that at all, is equal to the other cross, which is 1 times q. You can feel free to write 1 times q, but of course anything times 1 is itself, so what you could write is just q. Now I look over here and I see is q by itself? Yep. So I'm all set. Had this problem instead started like this, k equals q over n, same thing, but if instead it had wanted n, let's run through it again. I see a fraction, therefore I know it's division, so I put k over 1 so that there's two fractions, and I would cross multiply just the same way. And I would end up with, I did kn the first time, doesn't matter what order you go in, but let's go the other way first. 1 times q is just q, equals the other cross, k times n. And now I look, you'll notice this is, by the way, the exact same thing that I just solved for last time. But I look and see, is n by itself? No. But we literally just solved for this thing last problem. The same sort of way. Is n by itself? No. What's keeping it by itself? K. What's k doing? Multiplying. So to get rid of it, I need to divide. And I must do that on both sides, so it's equal. That cancels, and we're left with q over k is equal to n. N is by itself, so we're done. There's another mathematical way to do this that potentially your math teachers have taught you, and that is just as successful doing it this particular way. This is what I've found probably to be the easiest for our needs right now, but they might teach that to you, and that's completely fine as well, as long as you show your work. That's how to do it.